Welcome to this video on finding the sample size needed to construct a confidence interval for qualitative data. Let's begin. The objectives of this video are that by the end, when finding n to construct a confidence interval, you should be able to determine the appropriate equation to use, evaluate the appropriate equation for qualitative data, and to round appropriately. You may have heard the expression time is money. Well, this is especially true when you are collecting data. Suppose you are a contractor for a company. They ask you to create a confidence interval to estimate the population proportion of people living below the poverty level. However, they are only willing to reimburse you for 100 hours of work. Therefore, you cannot waste time collecting more data than you need. Instead, you must determine the minimum number of data points that will achieve the margin of error and confidence level the company has determined is acceptable. So, let's suppose that they tell you that they want a 95% confidence interval. So you know the confidence interval you desire. You also know the maximum margin of error your application allows, so they are specifying a margin of error of 2%. So given this information, how can you find the sample size that you need? The first question we have to ask ourselves is, what data type are we being given? So our two choices are quantitative data and categorical or qualitative data. In either case, we are going to begin with the equations that are used to find the margin of error in a confidence level. So for quantitative data, here's the equation, and for qualitative or categorical data, that's the equation. Then what we're going to do is, in both of these cases, we are going to rearrange the equation and solve for n. This is just a fun little exercise that you can do using algebra, so if you want to see it, feel free to see your instructor, or you can try it on your own. But the important point is that both can be rearranged and solve for n. So for quantitative data, this becomes our equation that we would use to find our sample size, and for qualitative or categorical data, this becomes our new equation. So in our problem, which of these two is appropriate? In other words, in our example, are we being asked to find the sample size for quantitative data or categorical data? Well, let's go back to our question and see if we can figure it out. So I encourage you to pause the video, see if you can find the answer, and then unpause it to see if you're correct. So you might notice this key word right here is population proportion. So that suggests to us that we have quantitative data. So therefore, we must use this formula over here. So let's see what information we need to collect to evaluate this equation and find n. Well, first of all, we have been given the confidence level, but you can probably tell from this equation there isn't a direct place to put the confidence level. Instead, we will use the confidence level to find z sub alpha over 2, and that is directly in the equation, as you can see. Then we are given the margin of error, and that does go directly into the equation. And then the last thing you might see over here is the p hat and the q hat. So what is that in this case? Well, the p hat would be a sample proportion that was collected from a previous study, and of course q hat is just 1 minus that. So given all of this information, then we have to find n. We have to find the sample size that we need. So we know that we want a 95% confidence level, and we know that we have a 2% maximum margin of error. So let's plug these values into the equation. So we've been given the confidence level, which is 95%. So we can use that to find our z of alpha over 2, and that's going to be 1.96. Then our margin of error has been given to us, which is 2%, so we write that as 0.02. So now, if we plug everything in that we have so far, this is our equation. But what about p hat and q hat? Remember, p hat is a sample proportion from a previous study. As you can tell, no mention has been made of that whatsoever. So what are we going to do next? Just pause this video and think about it. What would you do if your boss was demanding you to find the sample size and you weren't given all the information you needed? What would you do? Well, what we do is we take the worst case scenario. In other words, what is the largest value that the product of p hat and q hat could assume? So the easiest way to do this, in my opinion, is to simply just graph it. Okay? So remember that q hat is the same as 1 minus p hat. So we have this function here. We have p hat times 1 minus p hat. So we can just graph this. This is actually a parabola. It's a quadratic function here. And remember that p hat and q hat both have to be between 0 and 1 because they're both probabilities, right? So just looking at this red curve here, it's pretty obvious that this guy, this point right here, where the arrow is pointing to, is the maximum value. And you can see that that value, the maximum value of p hat times 1 minus p hat, is halfway between 0.2 and 0.3, so exactly 0.25. And that happens when both p hat and q hat are equal to 0.5. And if you don't believe me, you can type in 0.5 times 0.5 in your calculator. You will get 0.25. Okay, so what we can do with this formula is we can replace p hat q hat with 0.25 if we don't have any sample proportion from a previous study. So to review, remember we have to decide which formula to use. So we already know that our first dichotomy, right, our first information that we have to collect is, do we have quantitative data or categorical data, right? And again, if we have quantitative data, it's pretty straightforward. You just have the one formula. But now, if we have categorical or qualitative data, now we have a second thing that we have to ask ourselves. We have to ask ourselves, has a p hat, a sample proportion from a previous study, been supplied or not? If it has been supplied, then we can use that formula there. If not, then we replace p hat q hat with 0.25. So going back to this problem, right, clearly no p hat or q hat was provided for us, so we will have to take the worst case scenario, which again is that both of them are 1/2 or 0.5, and so we plug in 0.25 for p hat q hat, and when we do that, we get 2401. So we would say that 2,401 people have to be surveyed. And again, that should generate a 95% confidence level with a margin of error of 2%. So just for fun, just so that we can get better at this and get comfortable with using both formulas, let's suppose that we take that 2401 number to our company and then they get upset. They're like, oh, no, that sample size is too big. That's going to take too much time. So they scramble around and they say, you know what, we do have a previous study. You know what, the sample proportion from the last study we did was 0.31. So now we have p hat. Now we can actually use that other formula. So let's plug this in and see what would happen and see how our n, our sample size, would change. So here is our formula, and since we have been provided a p hat, we can plug that into our formula. Notice here, instead of calculating q hat, I just plugged in 1 minus 0.31, and I put that into Desmos, and this is the value that I got. So let's think about what we're calculating, right? We're calculating sample size. So we're saying how many people do I have to sample? So hopefully we can all agree that we can't sample 0.2956 of a person. So we have to round this one way or the other. Our sample size has to be an integer. So should we round this to 2054 or should we round it to 2055? So take a minute, pause the video, make a guess, and then unpause it to see if you're right. So before I answer the question, I'm going to give you some really, really silly examples, but it's going to make sense in a minute. So suppose you're going through the McDonald's drive-thru, you're going through for a late night snack, okay? And your meal is $7.30, and you give the cashier $7. Are they going to give you your food? Well, probably not, right? Why? Because you didn't really give them enough money, okay? What if your meal costs $7.06 and you only give them $7? Are they going to give you your food? Well, they might, they might be like, oh, it's 6 cents, don't worry about it. But, legally, they have every right to deny your the food to you, right? Because you really haven't given them enough money. So recall our normal rounding rules, right? Are 4 and below, leave it alone, 5 and above, give it a shove, something like that. And it's demonstrated here on this table, right? So 10.4, I would round that to 10, 10.5, and anything above I would round up to 11. So McDonald's, right, going and paying for something is an example where these rounding rules absolutely do not apply. Even if there's only a few pennies extra, I still have to give the cashier this much money or more, right? I could give the cashier a $10 bill and they would give me change. I could give them $8 and they would give me change. But I can't give them less than what my meal costs. So it's very much the same thing when we think about sample size. Normal rounding rules don't apply. Instead, if there's anything, even a teensy tiny little bit after the decimal point, I have to round up. And just The reason is exactly the same with McDonald's, right? I have to pay for my meal. I have to supply a large enough sample size to ensure the confidence interval and the margin of error that I need. If I have to give 10.001 and I only give 10, I haven't given enough. If I have to give 10.4 and I only give 10, I haven't given enough. So I know it's a little bit weird, but we can't follow normal rounding rules for our sample size, regardless of what the value is after the decimal point. If there's anything here at all other than just 0, then we must round up. So in conclusion, let's look at our question. Let's finally answer it, right? So it was 2054.2956. So we said, even though regular rounding rules would dictate that we just round down to 2054, in this case, right, again, think about paying for something. If I just give them 2054, it's not enough. I have to round up. So I have to round up to 2055. So if, like me, you're wondering, well, does it really matter? Did I make a significant difference in the number of people I would need to survey with or without p hat? Well, without p hat, remember we needed to survey 2,400 people about, right? And with p hat, we got that number down to closer to 2,000, right? 2,055. So that's a difference of more than 300 people. And remember, we said time is money, right? So that difference could make a significant difference in the amount of time and energy you put into your survey. So it could make a difference. All right, so to sum up everything that we've gone over in this video, because we went over a lot, the first thing you want to do if you're asked to supply the sample size to construct a confidence interval, first ask yourself, which data type do you have? Do you have quantitative data or do you have categorical data? If you have quantitative data, again, there's only one answer, there's one equation. And if you have categorical or qualitative data, then you have to decide, has p hat, that sample proportion from a previous study, has that been supplied or not? If it has, then you can use that formula right here. If not, we have to use the worst case scenario, which is that we replace the product of p hat and q hat with 0.25. The other thing that's super important to remember is that your sample size has to be an integer. So we cannot follow normal rounding rules. In other words, we always have to round up. So in conclusion, the objectives of our video were that we would be able to determine the appropriate equation to use, evaluate the appropriate equation for qualitative data, and to round appropriately whenever we're finding n to construct a confidence interval. So hopefully at this point you are able to do that.